Unit 10th. Oscillations. Waves. One part is oscillation and other part is waves. This is name of unit. Periodic motion. When a body completes each cycle or circle in same time, then motion called periodic motion. Example: motion of fan, motion of needle of watch, periodic motion. Circular motion, another topic. Motion of body in circle called circular motion. Example: motion of earth around its axis. Motion of live whale motion of fan, motion of needle of watch. These are what? Circular motion. Examples: oscillatory motion, to and fro motion, called about mean position, called oscillatory motion. Example: motion of simple pendulum, motion of liquid in U-tube. No question. This is a mean position. The particle here at mean position, it oscillates like this. Extreme position. Back to mean. Another side. Extreme position. This is a particle. It is oscillating about mean position. Extreme back to mean, then another extreme back to mean. These are what? Oscillatory motion. This distance OC OD called amplitude, maximum displacement. OA, Y, it is capital A. We denoted this with capital A. OC, OD, capital A, amplitude. OE, this distance called displacement. This distance, displacement, this displacement, this displacement, this distance, displacement, increase, displacement, displacement, yeah, amplitude. Maximum displacement is amplitude. Simple harmonic motion. S.H.M. Simple harmonic motion. A motion which is oscillatory. And periodic, called S.H.M means both things, oscillatory as well as periodic. Example, motion of simple pendulum, motion of balanced wheel of watch, motion of liquid in YouTube, balanced wheel of watch. वॉच को पीछे से खोलेंगे तो एक इस तरह का होगा, वहां ये ऐसे ऐसे करेगा, लाइक दिस. तो दिस इज मोशन ऑफ बैलेंस्ड व्हील ऑफ वॉच, मोशन ऑफ लिक्विड इन यूट्यूब. तो दिस इज सिंपल हार्मोनिक मोशन, बोथ थिंग्स. प्रॉपर्टीज of S.H.M. First property, it is oscillatory. Second, it is periodic. Third, acceleration is always directed towards mean position. Rough work. Suppose this is simple pendulum. It is oscillating like this. Maximum velocity. Velocity decreases, retardation in this direction. In this direction there is acceleration. Acceleration, this is mean position, this is extreme, extreme. When a pendulum oscillates, velocity maximum, then retardation start. Velocity zero, acceleration start. Kidhar? Towards me. Fourth, retarding or restoring force. Directly proportional to displacement. यहां से ऑसिलेट होकर यहां आए, कम होगी फोर्स जो वापस लाना चाहेगी. यहां आए थोड़ी सी ज्यादा, यहां मैक्सिमम होगी, इसीलिए स्टॉप हो गया. मीन एक्सट्रीम, इट इज स्टॉप्ड, देन बैक. The restoring force which tries to bring it back or retarding force, यहां से रिटार्डेशन स्टार्ट होगा, यहां कम होगी. ये all we will prove. So these are properties of S.H.M. Is motion of Earth around its axis. Is S.H.M a small question? The answer is no. Because it is periodic. Why? 24 hours each cycle, each circle, but not oscillatory. Equation displacement of S.H.M. Equation of S.H.M or displacement of S.H.M. Let a particle is moving is revolving with constant speed in circle of radius A. A is OX, OY, OX dash, OY dash. This is a particle, it is revolving constant speed. Let it reaches to B in time t from x, यहाँ से यहाँ t टाइम में थीटा angular displacement in this time, omega constant angular speed, then foot of perpendicular of particle will move from O to C in same time T। यहां से परपेंडिकुलर डालिए इस पर y एक्सिस पर C। यहां पार्टिकल है फुट ऑफ परपेंडिकुलर, यहां पार्टिकल है परपेंडिकुलर डालिए तो फुट विल ट्रेवल फ्रॉम O so on to C। when particle from A to B, X to B, then foot of that perpendicular will move from O to C। then OC is Y displacement of foot। ये जो परपेंडिकुलर का फुट यहाँ आया, परपेंडिकुलर y एक्सिस पर डाल रखा है, ये फुट है परपेंडिकुलर का, यहाँ है पार्टिकल, ये फुट, राइट। तो OC इज y। इफ दिस इज थीटा, दिस विल बी थीटा। पार्टिकल यहाँ है, फुट यहाँ आ गया, पार्टिकल यहाँ, फुट यहाँ, पार्टिकल y, फुट भी यहाँ, पार्टिकल यहाँ, फुट यहाँ, बैक। तो व्हेन पार्टिकल कंप्लीट्स वन साइकिल, वन सर्कल, again this is the particle moving in circle। पार्टिकल यहाँ, फुट यहाँ, पार्टिकल यहाँ, फुट यहाँ, यहाँ फुट, फुट at the same place, then here, then foot moves back। तो when particle completes one cycle, then circle, then foot will complete one cycle। So the motion of foot is oscillatory and it will be periodic, so it will be S.H.M। Now OC by OB, perpendicular upon hypotenuse, it is sin theta, or OC is OB sin theta। OC is Y, OB, it is OB also। Why? Radius. This is what? Radius. This is what? Radius of circle. So it is A sin theta. But omega is theta by T, or Y is A sin theta omega T। This is equation of S.H.M, or Y is A sin omega T plus phi naught। General equation of S.H.M, Y phi naught, initial phase। What is phase? We will just discuss। So this is equation of S.H.M, this is general equation of S.H.M। If starting point is not at mean position, not mean, यहाँ से oscillate करना start कर दिया, फिर mean पर आया, this is O। graph between displacement and time in S.H.M. This is time. This is direction of displacement. Y was A sine omega t. The omega t is omega 2 pi by t or 2 pi nu. If t is 0, 0, sine 0, 0, 0 into a 0, y is 0. T is t by 4, where capital T is time period, time for one cycle. Then 2 pi capital T, t by 4, pi by 2, y comes out to be 1. Here omega t is pi by 2, sine pi by 2, 1. So y comes out to be A. T by 2, 2 pi t, t by 2, sine 180. Again 0, again y is 0. 180 minus 1, sine 180, it is 0, so y is 0. T, 3t by 4, y comes out to be minus A if you put these values. Fifth, t is d, y comes out to be 0. This is capital T. This is t by 2. This is t by 4. This is 0. This is 3t by 4. T 0, y 0. T by 4, y A. T by 2, y 0, minus A. Again 0. So this is plot graph between y and t, or displacement as function of time. So how to plot? We will not do like this in future. If first 0, then for second it is maximum, third 0, fourth maximum in opposite direction 0. First 0, second will be maximum, third will be 0, fourth will be maximum but in opposite direction. तो दिस इज एंगल, फेज बोला था हमने कहीं एक वर्ड, फेज, फेज एंगल, फेज और फेज एंगल, फेज एंगल और फेज, from this omega t we find that particle is here at extreme, now again at mean particle. किसने बताया? ये ओमेगा टी ने. दिस ओमेगा टी इज फेज एंगल और फेज. तो व्हाट इज फेज एंगल और फेज? which tells about position and direction of a oscillating particle called phase. Example, y a sin omega t. If it is positive, then this angle here omega t is phase of y. ओमेगा टी ने ये बताया कि पार्टिकल ये है, यहाँ पर पार्टिकल यहाँ है, डायरेक्शन क्या है? अपवर्ड. यहाँ पर एक्सट्रीम पर है, ये यहाँ पर, फिर इस टाइम फिर मीन की तरफ स्टार्ट हो गया, यहाँ मीन पर. तो पोजीशन एंड डायरेक्शन ऑफ पार्टिकल, दिस इज कॉल्ड फेज. This was theta. B, C. Suppose the starting point is here. यहाँ है, ये है डायरेक्शन. Then this will be foot. Then y will be a sin omega t minus phi naught. This phi naught called initial phase. यहां से स्टार्ट किया, phi naught is 0, phase is omega t. यहां से स्टार्ट किया हमने सर्कुलर मोशन, मींस फुट. यहां से स्टार्ट किया ऑसिलेशन, यहां से एट दिस पॉइंट, पीछे से बैक. तो y इज a sin ओमेगा t माइनस phi naught. This is phi naught. Starting point is this. This was B, this was C, this was theta. Then the equation will be A sine omega t plus phi naught. The direction of motion is this. Suppose t is equal to 0 and this is direction of motion. Then y is a sine. अब यहाँ ये डायरेक्शन है तो ये पीछे रह गया, पीछे ओमेगा टी माइनस फाई नॉट. A projection is along x-axis. O, B, C, it is X. Then X, OC by OB, it is cos theta. OC, OB cos theta. OC is X. OB, it is a radius of this circle, cos theta or X. A cos omega t. A projection along x-axis, then x comes out to be a cos omega t instead of sine. We will get cos. So general equation will be plus phi naught minus phi naught as required.